Is this the landscape of a faraway planet or the surface of the moon? No, these images are from right here on Earth, the Great Lakes of North America. Scientists have been mapping the hidden depths of the largest freshwater system in the world. Now it's time to pull an imaginary plug and drain every last drop of water from these 5 massive lakes. We'll uncover an extraordinary secret world of cliffs hundreds of feet high where early humans may have lived, of lost river valleys and submerged waterfalls, a possible catastrophic alien encounter, and a unique glimpse into our own recent history. It's a once-in-a-lifetime journey as we drain the Great Lakes. They've been called inland oceans and freshwater seas. Their name reflects their grand size. Along their shores are natural wonders and soaring man-made skyscrapers. 34 million people call the Great Lakes home. We'll explore the depths of these massive lakes as never before and reveal secrets that have been hidden for millennia. We begin at Lake Superior, the grandest of the lakes, the largest, the deepest, and the most mysterious. Along the south shore of Superior is Pictured Rocks National Lakeshore, named for the colorful cliffs that rise from the lake bottom. It's one of the most spectacular locations on the Great Lakes. But it isn't just the scenery that makes this location unique. It's also what lies offshore, deep underwater. If we drain the water from Lake Superior, just 25 miles out from Pictured Rocks, what will we find? The hidden landscape of the deepest part of the Great Lakes Basin is revealed. Nearly 1,300 feet down, the height of the Empire State Building, no one has been here before. No light penetrates to this depth. It's truly an alien landscape.
Most people have this idea that a lake is just a simple bathtub, essentially, and I like to think of it that it's basically a record of, it records not only what's happening now, but what's happened in the past. You know, it's essentially a fingerprint.
Nigel Watrous has studied this area extensively.
Those valleys are pretty big. That's such a contrast to other parts of the lake that, you know, it really makes you sort of sit up and think about, you know, the processes that develop that type of topography.
The valleys at the deepest part of Superior were formed when ice ruled the land. 20,000 years ago, a massive ice sheet covers the area where the Great Lakes now exist in a blanket of white. The ice is likely a mile thick in some places. It would tower over the skyline of cities like Chicago and Toronto. For thousands of years, this enormous ice sheet presses down, reshaping the land, gouging deep holes. When the ice begins to melt and retreats, these deep depressions fill up with cold glacier water to form today's Great Lakes. Fast forward to the present day. The glacier's effect on Superior's lake bed can still be seen today. With the help of modern technology that allows scientists to see through the water column. Nigel and his team from the Large Lakes Observatory in Duluth, Minnesota, use side-scan sonar and multi-beam devices to map Lake Superior. Since sound travels easily through water, it can pierce even the deepest parts of Superior to reveal its shape and size. The multi-beam data collected gives us the ability to recreate the deepest part of Lake Superior in stunning detail. 1,300 feet down, we see how this great lake was formed.
Ice plays a role, but it's primarily acting as the cap, and it's the water flowing underneath, which is really carving those channels.
Water created the huge hidden valleys that run for miles at the deepest part of Lake Superior. The sheer weight of the glacier pressurized the meltwater. Sand and rock particles in the high-pressure streams carved through the bedrock, shaping them into deep, wide valleys. With the water removed from Lake Superior's lakebed, another strange anomaly appears.
Was very excited to see rings. I mean, this was really the first data set that I can think of that documented the presence of rings in the eastern part of the lake.
Superior is the only Great Lake where these unusual rings have ever been found.
The easiest way to think of them is imagine Paul Bunyan took a donut and he pressed it into the soft lake floor sediments. That donut would be about 200 to 300 meters across. Depression would be up to 5 meters deep. The width of the ring would be of the order of 10 to 30 meters. So, it's a sizable feature on the lake floor. We're thinking that these rings are the result of water which was at one time trapped in those very fine-grained sediments, getting released as a result of perhaps a catastrophic drop in the lake level.
These rings, born of changing lake levels, have been preserved on Superior's lakebed for thousands of years. Draining the lakes not only reveals hidden features like these, it provides a window to the past. Further south, we come across one of the most striking man-made features on the lakes, a huge suspension bridge that spans the Straits of Mackinac between Lake Huron and Lake Michigan. Stretching more than 5 miles, it is the longest bridge in the Western Hemisphere. Once a year, on Labor Day, the public is allowed to walk over the bridge and marvel at this engineering masterpiece. Its spans offer safe passage to large cargo ships passing below. Thousands of people take the opportunity to cross it on foot, but few, if any, are aware of what lies beneath it. If we drain the Straits of Mackinac, what will we discover? What visitors can't see presented a major challenge for the bridge builders many years ago. A deep channel that snakes through the Straits of Mackinac. A 24-mile-long, 1,200-yard-wide gorge runs right under the center of the bridge. But how did it get here? The Great Lakes were not always as they appear today. What occurred thousands of years ago to create this extraordinary feature? The answer could lie to the south, on Lake Huron, where evidence of submerged waterfalls as large as the present-day Niagara Falls points to even bigger revelations about the Great Lakes past. When we drain the waters from the Straits of Mackinac between Lake Huron and Lake Michigan, we uncover evidence of a hidden gorge under the massive bridge. The answers to how it was formed and when may be found further south, at the center point of the Great Lakes Basin on the tip of the Bruce Peninsula. Here lies the town of Tobermory, Ontario, an area rich with geological clues to the history of the Great Lakes. High atop the surrounding cliffs, there's evidence from more than 10,000 years ago of incredibly high water levels, the result of a sudden increase in the amount of water from melting glaciers. The high water marks of an ancient shoreline are easy to see, but there are more signs that aren't visible, offshore, hidden under the surface of the lake.
Tobermory region is quite unique in the fact that a tremendous number of features exist on the lake bed that tell you all about its history. The history of water levels going up and down. You can actually find most of the history as to how the Great Lakes drained by studying the lake bed here in the Tobermory region.
The idea that the water levels of the Great Lakes have fluctuated wildly over time excites many researchers and may help to predict the future of the region.
We have some preliminary maps of the lake bed here, and we're looking for early evidence that the lakes drained about at least 50 meters below their present elevation. Now, nobody ever thought Great Lakes water levels went that low, but we've learned that they did. Starting around 10,000 years ago, the climate was more arid, and lake levels dropped because of evaporation, and they eventually got very low, such that Georgian Bay was an isolated basin.
For years, it's been nearly impossible to prove this theory, since the evidence has been hidden under hundreds of feet of water for more than 6,000 years. But now modern technology may finally provide the breakthrough. The Canadian Hydrographic Service boat is equipped with multi-beam technology. A device on the hull of the boat bounces sound waves off objects on the lake bottom to build a map of the underwater terrain.
The biggest thrills for a geologist is to be able to actually see something in the 3 dimensions. We can move around, we can actually look at all sides of the channel. I can see where the water actually flowed over the top of the escarpment. And then I can actually see the plunge pool at the bottom.
Using this new data, what will it look like when we drain the water off the Bruce Peninsula?
If you've been here 7,500 years ago, the water here would have been totally drained, the escarpment would have been exposed, and we had river flowing from the north to the south here. It actually turned to the east at this location here and then flowed to the east and over the escarpment to form the Dunks Point waterfall.
Further mapping reveals that more river channels and waterfalls, some larger than Niagara Falls, existed off the Bruce Peninsula 8,000 years ago.
That's really key evidence. We now know that climate change will affect lake levels. For example, a meter change in lake level has an impact on the economy. We can look at the past and use it as a key to the future to help us understand what Mother Nature and what mankind is going to do to lake levels, and we can then determine what we need to do in the future to adapt.
Lake levels were once low across the entire Great Lakes system. Today the lakes are interconnected, so what affects one affects them all. But 7,000 to 8,000 years ago, each lake is a separate basin with few, if any, rivers running between them. The gorge under the bridge in the Straits of Mackinac forms at this time, when lake levels are much lower. Back then, the gorge is filled with a narrow river joining Huron and Michigan. The low water level exists long enough to cut and gouge the lakebed, leaving behind this evidence of an ancient river channel. The geology of the Great Lakes is recent enough that these events could have occurred when humans were already living in North America. But is there any proof of their presence? The answer may lie 50 miles to the southwest of Tobermory, in the middle of Lake Huron, where another striking feature rises off the lakebed when we drain the second largest of the Great Lakes. The Alpena Amberley Ridge extends across the entire lake. 7,000 to 8,000 years ago, it was dry land.
It's this massive limestone outcrop that resisted the ice sheets, and it exists on the bottom as a very striking column scarp of sheer rock that on the northeast side drops away hundreds of feet. So it's a very striking feature now, and it would have been even more striking when it was above water.
This land bridge was exposed during the same years that early Paleo-Americans roamed the continent. Signs of their primitive civilization may lie buried underwater.
From a historical point of view, it's important not just because of the sites themselves, but because they present an opportunity that we'd never have on land, in the sense that the sites are pretty much left just the way the hunters left them. It's like a Pompeii underwater, really.
Using an ROV, a remote-operated vehicle, John O'Shea and his University of Michigan team searched the lakebed for anything that might suggest the presence of humans on the ridge.
What we found to date are a series of stone constructions that are very similar to stone constructions that are made by modern caribou hunters in the Canadian Arctic.
It's only when we drain the lake that we see the stone line in its entirety. These may be so-called caribou lines, a hunting technique that relies on the animal's habit of following linear features in the landscape. Early humans may have built these stone constructions to help funnel caribou into killing zones. Until now, John and his team have been limited to ROV research.
In order to actually bring home the bacon and prove that we have the archaeological sites, prove that we have the artifacts, nothing to be done other than to put archaeologically trained divers on the bottom and have them systematically do this search.
John gets his wish. Divers descend the waters of Lake Huron to explore the lakebed. They may be the first people on the Alpena Amberley Ridge in more than 7,000 years. When we drain Lake Huron, the striking Alpena Amberley Ridge rises from the middle of the lake. 7,000 to 8,000 years ago, this towering cliff was dry land. A team of archaeologists believe they've discovered evidence of early man living and hunting on this ridge. When the water is drained away, we see rock formations that may have been used to corral caribou to hunt. A new expedition hopes to shed more light on the mysterious stones.
This is the first day that we're going to go out and actually do scuba investigations on one of these caribou drive lanes. And it's really exciting for us because in a lot of ways, virtually everything we see today, even on the first dive, is going to be really new. To be really honest, I mean, the Holy Grail is the humblest flake, the humblest chunk of fire-cracked rock that confirms absolutely that this was a human occupation site. "50
miles out in the middle of Lake Huron, divers descend to the ridge. They may be the first humans here in more than 7,000 years. It's like watching the moonshot. It's like watching Neil Armstrong. The divers have 45 minutes to gather as much evidence from the lake bed as possible.
There goes the basket.
The expedition is a success. Countless samples are gathered for the team to study and analyze. A tiny sharp-edged stone offers immediate hope.
That definitely looks like a bulb there. This would be typically a flake this size would be a bifaced trimming flake, a kind of tertiary flake where you're modifying the edge, you're fining up, or you may do it when you're resharpening or modifying a tool. And that's honestly why it is so very small. Yeah. Remember I told you the smallest, humblest little piece? Now this may be the smallest, humblest little piece, but we'll take it.
It will take more expeditions and detailed explorations on the surface of the ridge before John's suspicions can be confirmed. But the lake bed isn't done giving up its secrets. There's still more to learn from this vast, unseen territory as we drain the lakes. Further south, water flows from Huron to the shallowest of the Great Lakes, Lake Erie. On the north shore, we find a geological wonder. A land formation that extends over 25 miles into the middle of the lake. It's made entirely of sand, a byproduct of glacial ice grinding away at the bedrock. This feature is fittingly named Long Point.
In terms of the Great Lakes system, Long Point is almost unique. It's not unique in the processes that formed it. It's unique in its size and the scale of what's going on.
What is going on here? In geological terms, this colossal sand feature was created in the blink of an eye.
About 5,000 years ago, we probably would be standing in water because Long Point did not exist at that time. Long Point is built out into the deepest basin of Lake Erie to a depth of about 65 meters. So it's taken a tremendous amount of sand to build this thing up all the way to the surface.
Troy Holcomb worked with NOAA, the National Oceanic and Atmospheric Administration, to create the first detailed bathymetric map depicting the water depth of Lake Erie. With this data, we now drain Lake Erie. As the water level drops, we see two massive sand ridges, Long Point Escarpment and Clear Creek Ridge, hidden from view until now. Both of these ancient sand ridges almost bridge the lake. They were built by huge glacial sand deposits and formed when the water was much lower. 12 miles to the west of Long Point are sand cliffs, laid down by waters receding after the ice melted. These cliffs feed Long Point and probably helped build up the ancient ridges, a process of sand redistribution that has been going on ever since the glaciers retreated and continues to this day.
Today we saw geological processes at work, moving sand around right as we were there. This area is eroding away very fast. You can see mud, sand in the water. The wind is from the southwest, and so the longshore drift, the sand is going to be to the east. Eventually it will make its way all the way out to the end of Long Point. You sort of see the dynamics of all the sedimentation that's going on here, and it's happening now and it's happening fast.
Ancient sand ridges and present-day Long Point, both wonders created by the same force, shifting sands through wind and water. Downstream from Lake Erie is another place that has witnessed dramatic changes. It's perhaps the most spectacular landmark in the Great Lakes system. Niagara Falls. Every minute, 36 million gallons of water flow over the falls into the raging Niagara Gorge. All the water in the entire Great Lakes Basin travels through this narrow corridor. The power and force of the water continually cuts back the gorge. But back when early humans may have hunted on the Alpena Ridge, and the waterfalls flowed in the Tobermory area, Niagara's gushing roar was silent. 5,000 to 10,000 years ago, this is what we would see. The raging Niagara River is a trickle, and for a period of several thousand years, the falls dry up. With each of the upper lakes a separate basin, little water flows between Erie and Ontario. The mighty Niagara is not so mighty. Downstream from the falls is Lake Ontario. Draining this lake reveals striking clues to a turbulent past and an uncertain future. 5,000 years ago, water starts to rise throughout the Great Lakes. A tropical air mass settles over the Great Lakes Basin, and precipitation fills the lakes to present-day levels. Niagara begins to flow. Long Point starts to form. And in Lake Ontario, something unusual happens on the lakebed. Toronto is the largest Canadian city on the Great Lakes. 2.5 million people live and work near the Lake Ontario shoreline. The city has long been considered geologically stable. But not far from the towering skyline of the city, dramatic changes are underway. As revealed by the long ridges, laden with cracks, that crisscross the lake bottom.
What happened is that North America is under pressure. Would you believe that the area to the northeast, like Greenland, is pushing to the southwest? The area around California is pushing to the northeast. So it puts the Great Lakes region under pressure. And what happens under pressure is that the earth pushes up.
The resulting ridges are called pop-ups.
The pop-ups are a demonstration of the fact that earthquakes are occurring in the region and will continue to occur.
We don't normally associate the Great Lakes region with earthquakes, but the lakebed shows signs that seismic activity may be more frequent than we think.
It was only since the advent of multibeam we could actually clearly understand this network of cracks and fractures that have been thrown up into bedrock ridges.
These long ridge-like features are tectonic pop-ups. And what they are is compressional fractures in the rock. Like this piece of paper, the limestone here has compressed, and you started pushing on it from either direction, it would fold up in the middle. So this is how a pop-up is formed. What they tell us is that the lake isn't as geologically stable as we were led to believe.
With this detailed multi-beam data as our guide, we will drain Lake Ontario and see for ourselves what lies below Toronto's harbor. The number of interconnected pop-ups is staggering. They're 3 to 9 feet high, 15 to 30 feet wide, and run for many miles along the lakebed. With such clear evidence of seismic activity, what does the future hold for this area of the Great Lakes?
The history in southern Ontario is very low amplitude earthquakes. We have lots of very, very small ones. Will there be big events in the future that need to be taken into account? We don't think so, but that research is needed to make sure we build structures strong enough to withstand the anticipated largest earthquake or the largest force that will be placed on these structures.
Draining Lake Ontario hints at a shaky future, but it also gives a glimpse of a turbulent past. At the eastern end of the lake, a mysterious feature lies just below the surface. This is Charity Shoal, 12 miles offshore, right on the US-Canadian border. It's a shallow ridge with a lighthouse to help steer ships away from its dangerous shoals. Recent depth surveys have revealed a circular anomaly, but its origins are still a mystery. So today, Charity Shoal will be multi-beamed in detail for the very first time in order to collect more data. As the boat moves back and forth over the shoal, the strange feature begins to take shape, and a crater-like image is revealed. But what is a crater doing in the Great Lakes? Troy Holcomb from Texas University A&M has been interested in this feature for years. Now he wants to solve the mystery of its origin.
From what we've seen, Charity Shoal is a very old feature that has been re-excavated by glacial erosion. It still looks very possible that this is an impact crater, an extraterrestrial impact, but it's remaining to be confirmed.
To determine whether Charity Shoal is indeed the result of a meteorite strike, there's no better place to begin than the best preserved impact crater in the world, Barringer Crater, outside Flagstaff, Arizona. Barringer Crater is seemingly frozen in time. It looks much like it did 50,000 years ago, when a meteor traveling at 26,000 miles per hour slammed into the Earth. Could this be what happened at Charity Shoal?
I think is important for comparing with the Charity Shoal crater because both craters were formed in stratified sedimentary rocks, and both craters are about the same size. On Charity Shoal, we're seeing ridges that look like the exposed edges of bedrock at the top of the rim, just like you have here, only eroded in the case of Charity Shoal. Both craters are nearly round and have a continuous rim. They're both about 1.2 kilometers in rim-to-rim diameter. And this is an important feature because it means that both craters, if Charity Shoal is indeed an impact crater, it means that both craters would have experienced about the same projectile coming in and the same size of explosion.
Like Barringer Crater, a meteorite 150 feet in diameter could have plunged into the Ontario countryside, causing a 10 to 20 megaton explosion, creating Charity Shoal. When we drain Charity Shoal, we see the similarities. But this crater's gone through at least 4 glaciations and has been underwater for thousands of years. It's a shadow of its former self. But just maybe, millions of years ago, if you stood on the rim of Charity Shoal, it would have looked like this. A meteorite strike isn't the only dramatic atmospheric event to ever impact the lake's region. Violent storms regularly lash these inland seas, taking down giant ships, leaving behind their eerie ghosts on the lake beds below. When we drain the Great Lakes, part of our own history is revealed, scattered across the lake beds. Shipwrecks, nearly 6,000, spread out over 5 Great Lakes. Metal and wooden relics, hidden under the surface of the water, can now be seen in their glory. These shipwrecks are some of the most impressive sights to behold. when we drain the Great Lakes.
The large number of shipwrecks in the Great Lakes really speaks to the volume of shipping that was happening. So for a couple hundred years, when there's this really intense shipping going on in the Great Lakes in the late 18th and 19th and early 20th century, when this was the busiest waterway on Earth.
Russ Green works at NOAA's Thunder Bay National Marine Sanctuary on the shores of Lake Huron. Here, like many areas on the Great Lakes, numerous shipwrecks are scattered across the lake bed.
Lakes is a misnomer. I mean, this is the largest freshwater system on Earth. They are massive. They're treacherous, tough places to be if you're in a 130-foot schooner in the 1870s in November. The driving rain, freezing, caking onto your rigging. They're dangerous places to ship. Fire, storm, fog, shoal, human error, no radar, no GPS, lots of collisions just off here in Thunder Bay. All of these things contribute. It's the volume and the hazards contribute to why we have so many shipwrecks.
When we look down on the shipwrecks, another story emerges. The most recent and maybe most shocking story of all, a story of an alien that has infiltrated all of the Great Lakes and may be destroying them from within. In the 1980s, ocean-going vessels unknowingly transported an alien species of mussels in their ballast tanks. 20 years later, these mussels are reproducing at extreme rates and are changing the complete makeup of the entire Great Lakes ecosystem. The northeast sector of Lake Michigan, the Manitou Passage, is a stunning area. The sand cliffs of Sleeping Bear Dunes National Lakeshore tower over the passage that was once a major shipping route. But underwater, things aren't so pretty. Divers prepare to survey a wreck off the shores of South Manitou Island. The wreck is called Three Brothers. It was famous for being buried for most of the last century under sand until a decade ago, when shifting sands revealed it again to the world. Unfortunately, the ship is now a shocking example of the effect of the mussels. A form of algae known as Cladophora is growing at a phenomenal rate. As the mussels clarify the water, sunlight penetrates deeper into the lake, resulting in explosive algae growth. As the Cladophora dies, it collects in a thick, decaying mass near the wreck. The dead algae then releases toxins fatal to fish and birds. Here in the Manitou Passage, an environmental meltdown is underway.
It looks like there's a thick layer of mussel shells all around the outside of the hull. And here is the dead and decaying Cladophora. And boy, there's a lot of that down there.
I really think that's a profoundly dead Cladophora on the bottom. The volumes that are there are quite large, and seeing how it's worked its way around the wreck. It took some wave energy to get it there, but the fact that there's freshly killed fish means it has to be active in its decay and its production of the botulism toxin. The first thing I wonder is, where else is this occurring? To my knowledge, I don't know of other places in the lakes, but I can only guess that if it's occurring here, it's got to be occurring in many other places.
A mapping venture initiated by the National Park Service at Sleeping Bear Dunes and the Great Lakes Water Studies program at Northwestern Michigan College is using multi-beaming to help further understand more about this ecological problem plaguing Lake Michigan.
We're moving the system over what we call the Cladophora graveyard, and this is
The Cladophora Graveyard is the name given to the area around the Three Brothers. The team hopes that the multi-beam can give clues as to why this is happening.
And then there it is showing up in the waterfall image.
After a few passes, the multi-beam clearly shows the deep depression creating this ecological problem. The shipwreck sits right in the middle of a sand depression, and because of this geological feature, the algae is captured and decays in this area. How many more areas like this exist on Lake Michigan and the rest of the Great Lakes? They could spell the end of the Great Lakes as we know them.
I don't think I would ever doom our lakes. We've been here for several thousand years, and there's many thousand years to come. Our ecosystem is undergoing a severe challenge. The changes that have occurred in the last 20, 30 years are dramatic. The lakes are strong enough. It's just, what is the new ecosystem, and how will that new ecosystem evolve, and how will we interact with it?
Among the many legendary Great Lakes shipwreck stories, one stands above the rest: the sinking of the Edmund Fitzgerald. As we drain the Great Lakes, we've uncovered dramatic evidence of a rich and varied past, both natural and man-made, and geological wonders hidden from view. These inland seas were the highway into the continent, but the trail of wreckage left behind shows that the price of passage was high. Nowhere more so than the largest of them all, Lake Superior. It tests even the most modern of ships. On the south shore, Whitefish Point is known as the graveyard of shipwrecks. One particular wreck, 17 miles offshore, has taken on legendary status.
No doubt the iconic shipwreck of all the 6,000 that have gone down in the Great Lakes is the 1975 loss of the Edmund Fitzgerald.
The Edmund Fitzgerald, the largest ship to have sunk on the Great Lakes. When we drain the water out of Lake Superior, we can see this mighty ship once again.
It was probably the worst storm in 3 decades that claimed the Edmund Fitzgerald. It sunk in 535 feet of water without a single cry for help, and it took 29 men to the bottom with it, still remaining with the ship to this day.
Tom Farnquist knows the wreck of the Fitzgerald well. He's led 3 expeditions to the watery grave and is one of the few people to see it firsthand.
Our exploration of the Edmund Fitzgerald revealed a ship badly damaged. It was ripped in half. The forward section, which is about 200 plus feet long, is sitting almost on an even keel. The stern twisted off and fell upside down.
The side-scan sonar data shows the Edmund Fitzgerald sitting on the lake bed, 535 feet down. The images speak to the intensity of the storm and how quickly she sank.
If you were to drain Lake Superior, you would see the damage to the bottom caused by the impact of the ship. The rest of the lake bottom looks like a moonscape, quite smooth, little potholes here and there, but you get near the Edmund Fitzgerald, it almost looked like a snowplow had gone along and pushed the clay up on either side of the Fitzgerald. It literally plowed its way into the bottom. Maritime experts, naval architects, suggest that the Fitzgerald hit the bottom about 35 miles an hour. 27 feet down below the clay, it hit bedrock and started coming apart. This mountain of steel is in pretty good condition in some respects. The paint is there, it's very visible, you can read the name on it. So this moment in time is still well preserved by the cold, deep waters of Lake Superior. I've been on a lot of shipwrecks over a couple of decades, but nothing as grabbing or as moving as the Edmund Fitzgerald, knowing that 29 sailors in modern day went down in this shipwreck. It is still the most mysterious of all the shipwrecks on the Great Lakes.
Quiet and undisturbed, the Edmund Fitzgerald will haunt Superior's lake bed for decades to come. A reminder of the power and majesty of the largest freshwater system on Earth. A system whose secret underwater world has finally been revealed.